Hello and welcome to the webinar. Today's webinar is called Machine Design with 3D Printing, Efficiently Moving from Concept to Production. My name is Neil Cook from Onshape, and today I'm delighted to have with me Jason Camera from Cutsforth and also Andrew Edman from Formlabs. We like to make these as interactive as possible. So if you've got any questions to ask either myself, Jason, or Andrew, then please type the questions into the GoToWebinar question panel, and then we'll have around about 10 or 15 minutes at the end of the presentation to answer those questions for you. And with that, I will pass it over to Jason.
All right, thanks, Neil. So my name's Jason Cammer, and I'm the engineering manager here at Cutsforth. And today, in my portion of the webinar, I'm going to talk about a workflow that we use to design plastic parts, and namely plastic parts that have the end goal of being injection molded. And then we're going to go through a case study of a part that we designed this last spring, and then I'll pass it back to Neil from Onshape to go over some demos in Onshape, and then Andrew will talk about some stuff with Formlabs. So a little bit about Cutsforth. We are a company that's been around since 1991, and we develop parts for large power generators. And when I say large power generators, think of the type that keep the lights on. So large power generators that power cities. And one thing that I think is unique about Cutsforth that I've found in my almost 10 years here is it's a company that really focuses on using the latest technology and processes and really leveraging those to be quicker and more efficient at design and getting products to market. And that's really a shout out to our owners. That's a principle that they've really adopted and brought into the whole company. So when I mention large power generators, here's a schematic of how they work. So you have a fuel source and water that's boiled. That steam turns a turbine. That turbine's connected to a shaft that spins a generator, and out comes electricity. So one of the products I want to talk about in the case study is focused on this area right in between the turbine and the generator. So there's times when you have droplets of steam that are contacting turbine blades, and they basically make a static electricity that needs a preferred path to flow to ground. So we make a product that's called our shaft grounding assembly that installs on the shaft in between the turbine and the generator, and it gives a preferred path for those stray voltages to go to ground. And what that does is it protects the bearings in the generator, because without a preferred path to ground, those stray voltages will simply go through the bearings and erode the bearings. So this screen capture in the bottom right of this is an Onshape model of a scaled turbine power generator. So we use this model in Onshape, which I can switch to it, to communicate designs to customers. And we have all of our products installed in this particular generator. We make products in this area and in this area, and we store them in different tabs in the workspace. So we can quickly get a customer on a web meeting and go through those different products, and the end result is just a better understanding of the parts that we're trying to install or the information that we're trying to get from the customer. So some unique design constraints for the area that we live in and innovate parts for is it's the power industry. So these generators run all the time, 24/7, all year long. They often come down only once a year for about a week, and that's our outage window to install parts. So we have to be on time and on budget, and those parts need to be completely accurate. And the parts we're designing go into high vibration, high heat environments. They're dirty, loud, greasy, and definitely challenging environments for plastics to live in. So when we're designing parts, this is the typical workflow that we use. So as I mentioned, we do our designing in Onshape, and one of the main reasons we like Onshape because we were early adopters of CAD in the cloud, and we started probably 7 or 8 years ago with some of the products that NVIDIA made, and when those were end of life, that's when we found Onshape, and we've been plowing forward with that ever since. But one of the main reasons we like this is we can have 2 to 3 people or more working on a specific design or an element of a design at one time. And there's times when we need to chase perhaps 2 different paths on that design. And so we can have an engineer on path A, an engineer on path B, and then we can evaluate those towards the end and pick either path A or path B, or there's times when we'll merge 2 branches together and have a combination of both. And when we get to a point where we need to further evaluate a prototype, our preferred method in plastic part design is to 3D print either that element or the whole part, and then analyze it, go back to the drawing board and Onshape if needed, and then stay inside of this loop right here. We like being in this loop because it often saves time and money, because we can double up on the people designing the part. It's easy to send parts right to the printer. There are times though where we need to, it's faster for us to change a 3D printed model or a 3D printed part with our CNC machine instead of remaking or reprinting the whole part. So there are times that we'll use our CNC machine. That's what this icon represents here. There are times that we'll use this in this phase of the process. So once we get a little closer to finalization, we do some final product testing. That's what this hammer represents. And then when we think we've got the design fully ready, we will CNC machine one final prototype. And the reason we CNC here is we're typically buying a block of the exact material that we were intending to injection mold, and we'll CNC machine that part so we can do our final fit, form, and function test with that actual material with the tolerances that we expect to get from the injection molding. We try to just machine one final prototype at this stage. That's ideal. Sometimes we hit it, sometimes we don't. The reason is this is a very time-consuming and expensive process because we're machining draft, we're machining thin wall features, ribbing, all that kind of stuff. We recently finished a project where we got to our final prototype and we machined a part, and the spindle was running for 4 days. So that just represents a lot of time. So we don't want to have to repeat this process. But machining that part out of a solid plastic that we know is going to be injection molded, that gives us the confidence to move to purchasing the injection molded tool. It's always fun to see other people's collaboration space. So I threw this slide in here. This is a picture of an area that we often have stand-up meetings and talk about different designs and prototypes. You see our Formto printer in the background. We have offices that horseshoe somewhat around this table, and we'll have meetings here and discuss parts as they come off the printer, and then talk about next steps that we need to do, and then go back to our computer stations or to the workbench and make it happen. You can see our homemade UV curing bucket here. We use that to post-cure different resins. I'm broadcasting from the Pacific Northwest where we don't often have a lot of sunlight, so we have to make it artificially. At least we don't tell people we have a lot of sunlight because it's a secret place to live. All right, this is a cupboard that has all of our different resins in it. This cupboard is right underneath the table. We have different trays loaded with different resins, and this having all these stocked in this pantry just helps us to be able to try different resins as we're evaluating different features, like maybe a snap fit or a living hinge or flexibility. We can do all that and approximate that with this pantry of different materials. So as I mentioned, we wanted to talk about a particular case study where we use this workflow. So in spring of 2018, we were getting ready to launch what we call our assurance monitoring system. So I mentioned in the beginning that we have a product that we install here called our shaft grounding system that is connected to a monitoring system, which is a a stainless steel box that has a computer screen inside there, and it gives the power plant user the ability to see live voltages that are being taken off the shaft and current, and gives some other information as well. So we needed in a short time frame to be able to design some plastic covers that went around a display screen and protected a circuit board. So here's a picture of the finished product. This is being installed on a generator and going through its final validation testing right now with this voltmeter. But this is the computer screen we were trying to protect. So there is a plastic piece that's mounted behind the screen, and it's connected to these different measuring points here. And then there was another piece that had to connect into that. So here's what it looks like in Onshape, and we can peel some of the layers of the onion back here and take a look at this. So if I open this door, behind here is a plastic piece, which I apologize, that might be mated right now. But I have a picture of it in the upcoming slide. So plastic pieces that are behind this display screen. So you can see them both right here. They're probably 8 inches by 5 inches. Lots of different ribbing and features that are inside there, and some specific design criteria for this part. It needed to fit securely and made up with more than a dozen different pieces. There are screws, there's PCBs, test points, there's cables, lots of different parts connect in this area. It had to be designed for injection molding, so all the standard things for that, draft, uniform wall thickness, etc. And survive a temperature, max temperature of 149 F, 65 C, be able to live in a vibrating environment, and then make it nice and tidy in there, provide cable management. So just some analytics on this part. This design started in January 5th, 2018. You can see here, this is one of the first parts that we printed, and then these are just different versions. So from a management standpoint, it's when I'm looking at different CAD processes or processes that we do internally, it's nice to be able to go back and look at the different dates and how long it took to get from here to here. And as we go through some of the next slides, you'll see this timeline of how long it took us to go from design to actually ordering the injection molded tool. Before I hand it over to Neil, I'd like to show just a couple of pictures of these parts as they went through the different phases in the design. So I'm going to switch my cameras here. So these are some 3D printed parts that were very early on in the development of the plastic screen shroud. So as I mentioned, we sometimes will just print a small portion of a design. So this was when we were looking at trying to figure out a way to do cable management behind the screen. So instead of printing the whole device, we just printed this, some holes to screw it down to a bench, and we just do a lot of backyard testing, or we'll pull on the part or hit it with a hammer just to get a good feel for it. So that was printed out of the black resin. This was a part where we were chasing down a path of doing a living hinge. We ended up abandoning this for various reasons, but we printed this to evaluate living hinge, and then there's some snap fit features in here that we were developing as well. From there, we went into printing something that was more getting closer to the full size. So that living hinge piece was replaced with this being integrated into the part. We're starting to develop some of the ribbing and the different pieces in here. So next was closer to an actual part where we got this goes underneath the metal faceplate that I showed in this slide. In this piece, we were looking at the connection between the two plastic parts and how they interface together. And then next, this was a CNC part. So we machined this part because we were getting really close to being ready to injection mold. And then here are the two injection molded parts. So these were the first runs off of the tool. And then you can see, and this is how they interface together and protects the screen and the PCB. All right. So next, I will pass this off to Neil, and Neil's going to show us some items in Onshape. So Neil, can you go ahead and take over as presenter?
Sure. Okay, so I want to just spend a few moments talking about Onshape. Cutsforth have made a sizable investment in Onshape. They moved from an older style file-based CAD system, and one of the main reasons for that is being able to work simultaneously, a whole team be able to work together on the same project to be able to get things done faster. Also communicating with suppliers, communicating with people on the shop floor can all be done through Onshape without any extra tools required. Now, this slide is supposed to represent that typically a CAD system would be a 3D modeling tool, and then there'd be data management bolted on to manage all the files. Now, Onshape was architected completely the other way around. So it starts off with data management, and then we've built CAD tools on top. And then to cap it off, it's all hosted in the cloud. So all you need is a web browser to access it, which means you can run it from any type of computer. So it could be a Mac or Windows or Linux or even a Chromebook. And you can also run it from mobile devices like tablets and phones as well. Now, one of the ways that we work with Onshape, and if I just dive into Onshape real quick here. So this is when you first log in, you see all the projects that you're working on, then you just go ahead and click a particular project and then the 3D model will appear. Now, because there are no files and it's all driven from a database, when you need to work with somebody, a third party or even another team member, you don't have to email files or put them on FTP server or use Dropbox or anything like that. It works very much like Google Docs. So if you want to share a document with somebody, you quite literally hit the share button, put in their email address, or you could go to a team or the entire company. So if I just put myself in here and then specify what kind of permissions that person should have. So if you're working with a supplier for the first time, perhaps it's for an RFQ and it's not a trusted supplier yet, you can set them to be view only, but allow them to have commenting permissions. So when you go ahead and share that, they will receive an email with a link. They click on the link. If they already have an Onshape account, they can go ahead and open this your document and view it and make comments. If they don't, they'll be asked to sign up and create an account in order to do that. All they need, therefore, is a web browser, so they don't need to install anything or download anything. So it's a very efficient and very quick. Once somebody has, or you can change all these permissions. So if again, from the supplier standpoint, if you accept their quote and they are a trusted supplier, you could give them export permissions, for example, to export to their CAM package if they're using Mastercam or something like that. Or if they are a contractor, you can actually then let them have full editing rights. You can disable things like copy, but you might want to allow export. You don't want them to share it. We'll allow them to link it, and then just go ahead and update that. And their permissions will go and get immediately updated. So there's lots of things here that's helping you with from a security standpoint. So you're not emailing files around and you don't know where they've gone once they emailed them. And also at the end, if you decide that you don't want to share with that person anymore, you just go ahead and click the X next to their name and their permissions are revoked immediately. So there is no worry about files being out in the wild. You've got full control over your data. Okay, so what actually happens then, and I'll do this, let's see if this this works. Okay, so this is my iPhone 7, and I just running both at the same time here. So once we've actually received that email link, you can go ahead and open that document, and then once you've opened it, you can see then straight away that that my face appears here to let me know that somebody else is actually editing the document. So the idea here is that you can have more than one person working on it, but what we're looking at here on the phone is not just a viewer, it is the full CAD system. So you can do things like going to follow mode. For example, if I double click on my face there and then operate the phone, you'll see that it changes and rotates at the same time as the phone. So it just allows you to be able to do design reviews, for example, very easily. But also then if you wanted to make a design change, what you'll see is if I want to go ahead and modify one of these fillets, I'll use the modify fillet command and go ahead and click that face there. You'll see I'm actually in the full CAD system. So it's not just a viewer. You can see there's the feature tree that's sliding out from the right. But also what you'll notice is that if I scroll down to the bottom here, is that it tells me that somebody, this other person called Neil, is creating a new feature. Now, this enables me to work multiple people on the same document. Now, typically people do this in an assembly, so it might be assembling parts together at the same time. But you can edit the same part. You can even edit the same sketch at the same time. So let me just go ahead and let's go ahead and edit this sketch. And if I press this final button here, it's pretty cool because it shows you what the results of your modifications are. Now, while this is going on, let me just make another design change over here. So this is two people modifying the same design. If I can find it, there it is. And then I'll go ahead and change that. And then let's make that 0.1 or something like that. So we've got a nice big fillet. Now, it doesn't actually show up on the model I'm editing on the left here yet because I've not committed the feature. I've not pressed the check mark on the phone. But you see, I can quite happily go ahead and start modifying some of these dimensions. Let's say 1.5 inch, and that's going to rebuild the model. And obviously all the fillets and all the walls are all going to update for us automatically. But you see, as I go ahead and press the check mark on the phone, just watch these fillets here in the corner. As soon as I do that, you'll see those fillets update for us automatically. So that's going to just show you that whenever you've got teams of people working on the same design, you will actually see the changes happen as they happen. So you know what somebody is working on. You can also do things like create branches as well. So if somebody's creating an ECO or something like that, then you can go ahead and create a branch and do all the changes there. And then when you're finished, merge those changes in. So as soon as I, let me just zoom a bit out on the phone there. As soon as I press OK on here, you'll see it updates on the phone. Okay, so you've got this interactive real-time collaboration that you can do between teams. This is one of the biggest benefit that you'll get from Onshape. Let me just turn that screen mirroring off. Now, what you'll also see is that there is no save button. So every time I do something, it is recorded for the lifetime of this document. So just expanding this versions and history here, we can see all the changes that have been made to a particular design over time. So if you highlight, it tells me whatever change has been made today, or even, well, it's only yesterday that I started this model, but you can then do things like comparisons between, see what changes. You can see this branch here. So I branched off a very early version there, did some changes, do comparisons between these two to see exactly what those changes are. And if you like the changes, merge them together. So there's a lot of data management capabilities built right into the 3D modeling that you don't have to concern yourself with. It all goes on and quite happily goes on in the background and takes care of all your data. Now, from a 3D printing standpoint, once you get to a certain point, you would then perhaps create a version. And I know Jason uses versions to bookmark when significant events happen within the design. You can do the same, create a version. But once you do that, you just go ahead and right-click a part and export. And you can export that in a number of standard CAD formats. But for 3D printing, then STL format is the one that you want. Now, from regards to, you can specify which units you want to export in, and also the resolution, which goes from coarse, medium, or fine. Custom allows you to set the angular deviation, call tolerance, and minimum facet width. So these are overrides, if you like, which prevent a file getting too large or indeed too coarse. So, for example, the angular deviation is the angle between two facets. The caudal tolerance is the distance between the actual face and the facet. And the minimum facet width is exactly what it says. So one of these overrides, this one takes preference over this one takes preference over this one. So once you start to do 3D printing, you will come up with some figures which work well for you. So quite a lot of people will do medium if they're just doing some testing, and then fine is usually good enough for most people for when they want to do the final print. Now, the options here, finally at the bottom here, is you can either download that, which you will need to do in order to put it into your Formlabs printer, but you can also store it in a new tab within the document. Now, because this is all driven from the database in the cloud and version control with the built-in data management, it means that you can create something like an STL file and store it within the document. So perhaps you are off-site, at a customer site, you've finished making some design changes, you've set the settings that you want, you can then store that STL file within the document and then just let somebody know back at the office that this is the document and this is the STL file you want them to print. So they can just right-click and download and then do whatever they need to do with it. Okay, so that's what I just wanted to say about Onshape. One of the biggest benefits and one of the biggest reasons why people adopt it is just simply how easy it is to set up and get up and running with, but also really the collaboration features which are built in at the core, and all the data management features, again, which you're paying no extra for. All right, so at this point, I'd like to pass it back to Jason.
All right, thanks, Neil. So as I mentioned, we printed 3 different versions of this model, and the next slide we're gonna have Andrew take over and show us a demo in Formlabs.
All right.
So, Andrew, go ahead.
All right. Yep. So I'm with Formlabs. We're probably best known for our SLA printer, which the Formto, which I'll be talking about today in the context of product development and prototyping, particularly for kind of moving towards manufacturing validation. So this is a look at Preform, which is our print preparation software. And you can see you have all the usual tools that you'd have in any kind of printer CAD program: ability to rotate the model, ability to apply supports that are either automatically generated or manually added or edited. You can move the model around. This part is like fairly close to the extent of the build volume, so it's going to take up a lot of the build volume. So we want to angle that part, and then you can see kind of orienting it in space. Then there's a one-click support option, so you can automatically generate support structures. This is going to be printing upside down. It's kind of an inverted SLA process, we call it. So you click generate selected. You can see there's a few options there in terms of density of those supports and also point size. So those are settings you can play with. By default, we go with a pretty conservative setting so that you have really successful prints regardless of geometry. But as you get used to different materials and the print process, you can kind of dial those in to be a little more minor and support the parts a little bit less. And then it just goes through a process of generating those supports, adding those structures in place. You can see here scanning through the different print layers. You can see which areas are supported. It'll flag any areas that are under supported or might need additional attention, and you can go in and edit those supports manually as well. Oops, So this is a close-up. You can see all these little dots represent support structures, or where those support structures have their sort of root on the part, and you can move those around, you can delete them, you can add them. So this is really helpful if you have particular fine features that you're going to be checking dimensions of and really dialing in, moving towards manufacturing, and you want to make sure those are accurate. Those might be good places to shift support points around and support the part in a different location, or angle the part a bit differently so you don't have as much cleanup and you can trust the dimensional accuracy of that part. So SLA is really known for dimensional accuracy and smooth surface finish. So it's a good tool for this kind of manufacturing validation process that they're going through at Cutsforth. Just to kind of build on that manufacturing validation for small parts, you can even print an injection molding tool and get a couple of shots and test real plastic. That's with smaller parts, obviously, but a good thing to be aware of. And really, this is all just trying to address DFM questions before you commit to tooling or even commit to making a CNC prototype, just because that can take some significant time and money, as Jason mentioned. And sometimes you're putting a part into a process and you want to test around that. So you're overmolding as part of your product design. You can print out that part and overmold around it and validate that before you are using a full PCBA kind of assembly. So this is an example of an injection mold printed on a Formto with our high temp resin. And I think one thing that's interesting about SLA and how SLA has changed in the last 5-10 years is just the materials have become a lot broader and more robust, so that you can do more real manufacturing validation stuff. Before, you're really dealing with quite brittle materials that didn't have a lot of ability to undergo stress and strain, so you're really just kind of fit and function testing to a minimal degree. You couldn't even do like snap fits very well in the past, but now we have resins like durable and tough and high temp that have a range of mechanical properties. So durable is a material that Cutsforth is used in prototyping, and you can do things like surfaces that have low friction, so feel like kind of an HDPE or polypropylene, that have high elongation, so you can do snap fits and really check some of those design features that any plastic engineer is familiar with, but is traditionally kind of hard to test and validate before going to tooling. Should be advancing. Just to cover a couple others here, we also have a glass-filled resin that's really stiff and has good creep resistance. If you're going to use a glass-filled plastic, say in your end production part, that can be a good option to kind of validate there. Or high temp if you're dealing with a really demanding environment, like some of the environments that Cutsforth products end up in. It can be good to prototype in a material like this, where you can put it in a real context and get some feedback from users and get some feedback from your engineering team on how it holds up under those kind of stress and strain situations. So those are just a few to call out. We have a bunch of different engineering materials that can be used for functional prototyping and pre-production planning. So we have stuff that mimics rubber materials, stuff that has a bit more impact resistance and stiffness. So you can see on our website kind of a range of applications that different people are using in manufacturing and product development. And from there, I'll turn it back to Jason to talk about wrapping up their move into final production.
All right, thanks, Andrew. Okay, so we moved, our design started on January 5th. We moved through 3 different printed versions, and we machined one final version, and then we ordered the injection molding tool for this part on March 1st. And then our first assemblies shipped on March 28th. And then our first installation, which was that picture I showed earlier in the slide deck, happened on April the 12th. So I think it's a pretty quick timeline when you look at the size and the complexity of, it was actually two parts that I went through in this particular assembly that protected the computer screen. So I think that's a pretty quick timeline from design and prototyping to the first shipments of the assemblies. So we attribute that to being able to collaborate on designs in our CAD system and put multiple resources on a particular design or on a particular element of a design, and then just being able to work in a tight group that we've got really good people here, and they're good at being flexible and changing directions and our equipment with our CAD system and our printer and CNC machines, we're very agile with those tools as well. So I think just being fast and flexible, especially in this innovation stage of the process, is a key to getting products to the market faster. All right, so Neil, do you want to talk about the demos that people can do with Onshape, and then lead us into the Q&A session?
Sure. So thanks very much for that, Jason. I would just like to wrap up with just an offer to all our viewers. Onshape, of course, you can go to onshape.com and you can sign up for a free trial if you like to just go ahead and try out the software for yourself. But if you've got a bunch of questions, if you've been using 3D CAD for years and you want to see how Onshape stacks up against your existing CAD system, then please go to onshape.com/demo and you can register for a live demonstration. We're quite happy to go through any questions you've got in a one-on-one session. And as I said, just go to that that URL, onshape.com/demo, or you can request a demo simply through calling Onshape if you prefer. So with that, I'll pass that over to Andrew.
Yep. So as I mentioned, we have a range of engineering materials. Kind of depends on what plastics your team is mostly working with, but we have a range of different materials. So best way to kind of evaluate the technology and see if something will work for you is to go to the website and order a sample part in the material that seems like a good fit for your application.
Okay. All right. So we'll go over to questions. So let's see. So a reminder, if you've got a question and you'd like to ask either myself, Jason, or Andrew, then please use the question panel in the GoToWebinar dialog there and type in your question and press send, and then we'll endeavor to answer those questions for you. Okay, so we have a question here, one for Jason. How do you determine which resin to use in order to approximate a certain criteria in an injection molded part or even a CNC part? It's a question for you, Jason.
That's a good question. So we, like I think I showed that slide that shows our pantry of different resins. We will usually pick the resin that represents the particular feature that we're going to test. So if we're going into a high heat environment, we will and we need to do some heat testing, we'll use the high temp resin. If we need to evaluate something that's flexible, or maybe like needs a polypropylene type finish or functionality, we would use something like a durable. So we'll typically just evaluate the property in maybe a couple of different resins to really dial in that specific feature or specific criteria that we want to test.
Okay, let's have a look. Okay, there's a question here. In low volume boutique production, can one use the printed pieces as final in the build rather than just a prototype? Examples might be custom bezels or connection pieces. I guess that's a question for you, Andrew.
Yeah, so it really depends on the application and the part design. We do see instances where people are using SLA parts in a final assembly for a product. We have a customer that I just visited in Wisconsin that makes aftermarket car parts, and they were using printed components in SLA resin, usually tough or rigid, as part of a mirror assembly, carbon fiber with an SLA part, motor, bezel, mirror, and they had designed it so that it wasn't taking a lot of load or stress or strain. So that's usually what I advise, just because SLA materials do change more over time than a traditional thermoplastic in a lot of cases. So as long as it's designed properly and you understand how that material will work over time and what stresses it will be subjected to, it can work. but it is something you want to be careful to validate, because they're not one-to-one the same as thermoplastics. They're designed really to simulate, mostly for evaluation purposes and sometimes limited usage. And if you're planning to go beyond that, you want to do some extra validation steps just to be sure.
Okay. Guess this next question is both for Jason and Andrew. One is specific to Jason, one is generic for Andrew. I guess it's saying, which resin is used most often? Is there a more widely used one? So
I can take that as far as for us. I do most of the ordering for the resin that we use on our team, and the black resin is the one that we use the most. We find that it's a good mix of properties of print quality and also just mechanical strength. So yeah, we burn through that resin quicker than any other one. That's like this example part that I showed earlier. It's black resin. It finishes nice too. So this part we did some sanding on. I have some other parts out in our shop that we've machined this on the CNC mill to change features after we've printed it. So it works well. And another thing that you can use this resin for any of the machinists in the audience, if you've got an odd shaped part that you need to hold, you can easily print inserts for Kurt Weiss jaws or other fixturing pieces. It's just a way to be able to quickly make fixturing to grab odd shaped parts for machining or thermoforming or other processes as well.
Okay, and there's actually a follow-on question there. It's just which it is for both Jason and Andrew as well. But what do the resins you use consist of? The epoxy, or what's in the resins?
Yeah, they're photopolymers. They're mostly acrylate-based materials, but we do have some filled materials. So I mentioned the rigid material, which is glass filled, and we also have a ceramic filled resin that you can use where you print a part and then burn out the photopolymer component, and you're just left with a net ceramic part. So that's a bit trickier to use. So that's under our Form X kind of brand, which is a bit more experimental, more of a learning curve. The rest of our materials are really designed to be plug and play, but they're all acrylate based.
Okay. Question for Jason. How were you able to determine the design of the component so that it was meant for machining or injection molding versus for 3D printing, and where you could do whatever features you want?
Sure. So a lot of these two parts that we looked at in the case study, we knew that they were going to be injection molded, and that decision is mainly volume and complexity. So we knew the end game was going to be injection molding. Working backwards from that, I know we can print things in the Formlabs printer that not necessarily could be injection molded, so undercuts or complex slides. So we do evaluate that in our design process, and we have some designers here that are just really good at designing plastic parts and considering draft and undercuts and slides all the way through the design. There are times when we get closer to the final design that we'll consult with a tool maker to just make sure that we didn't miss anything, and we'll do mold flow analysis and tooling analysis just to make sure that we're not designing something that can't be made. But we usually start with an approximated volume of the parts to be sold, so we'll know our particular manufacturing process. But there are times where we need to install a prototype in the field and do testing, and that's where we'll tend to, in extreme environments, we'll machine that part out of plastic before the injection molded tool is made, and that's it's all on a case-by-case basis.
Okay, question for Jason. Do you ever find that you've moved too quickly and end up missing something in the final injection molded part?
I wish the answer was no, but it does happen. I mean, we're all human, but I think we're just very flexible as a team, so we can take something like that we missed, let's say in an injection molded part. And we actually had to do this recently where we missed a feature in there to access an adjustment screw because something on a PCB had changed later in the design. We'd already ordered the injection molded tool. So we'll just take those parts, make a fixture, or get them into the CNC or drill press somehow and modify them. So we just, culturally, we have a mentality here where we attack the problem and not the person. And so it's an approach that works well for us, and we'll usually get a lot of people, a lot of brains on one particular problem and come up with a creative solution very quickly. And quite often that with these plastic parts, that means getting them into a machine and doing a quick modification. And then once we sell enough of them to pay off the tool, we can look at doing mold modifications or perhaps cutting a new mold if we need to. But usually as we're ramping up a product and getting it into market, it tends to be a modification to the injection molded plastic parts.
Okay, another one for Jason. Do you ever have to outsource prototype parts? And if so, do you send vendors a 2D drawing or an Onshape link?
We do. We at times need to send out prototype parts. I mean, we have a very capable prototyping facility here, but things like sheet metal and investment cast parts, those are things we don't do in-house very much. So we will, it actually depends on the vendor. We try to send them whenever possible a link to the Onshape model, and then just give the vendor a quick demo on how to measure and get the dimensions they need, or just a lot of times they just figure out how to export it to a Parasolid or IGES file and get it into their CAM system or their whatever system they need to create their machining CAM from. And then for like vendors like sheet metal, a lot of times they tend to want flattened parts and drawings. So we'll tend to just make a drawing and export a PDF in Onshape and send that to the vendor. And if they need a DXF, we can export that and give it to them as well. So it's a hybrid approach, and it really depends on the vendor, but I find that it's pretty easy to do any one of those approaches with Onshape.
Okay, question for Andrew. Andrew, how have you used SLA to create a mold tool, example overmolds? Is there a resin that works best for this use? Are there any special considerations to keep in mind while creating a mold tool using SLA?
Yep, so generally high temp resin is used for that. The caveat there is it is quite a brittle material, so you need your dimensions to be really lined up. So sometimes that can mean doing like a fly cutting pass on those faces to make sure they align. Generally, it's going to be better for smaller parts and smaller shot sizes, and it's not. I don't talk about it as a short-run production tool necessarily. I talk about it more as like a validation tool. So it's when you need to get a couple of shots in your final thermoplastic because you want to do some stress or strain tests or some extended lifetime tests on it before you commit to tooling. So especially in certain products where you might have Class A finishes on those surfaces, that's a really expensive tool, and so it's worth doing some prototype tools, getting a couple shots in that material, and making sure the mechanical performance is there before you commit to tooling. So it's case by case. I mean, some people also consider aluminum machine tooling to be prototype tooling. It all depends on the volumes that you're ultimately looking at and what answers you're looking to get to at that stage of product development.
Okay. Another question for you, Andrew. The Formto has been out for quite a while now. Is there any development for a successor? Also, has there been any thoughts as to creating a Formto with a larger print volume?
Yeah, of course, this is a question we get all the time. We have a big team here. We're obviously working on lots of stuff, from materials to software to hardware. So, I can say that we're working on new stuff all the time, but I don't have any formal timelines to share with anyone or announcements. So.
Okay. Question for me, so I'll take this. Does Onshape create DWGs? Is the market shifting towards only using Parasolid step part files versus DWGs? Yes, we do create DWGs from drawings. You can select a face of a part or a sheet metal part and export in DXF or DWG, but primarily that is a drawing exchange format, being DXF or DWG, matters neither way. For 3D models, for machining directly from a 3D model, exporting in STL for 3D printing, everything is moving towards 3D models. So yes, so the options there if you need to send somebody an actual drawing that they need to open in, say, AutoCAD, for example, but like Jason mentioned as well, sometimes the PDF of a drawing is actually a better quality of drawing that somebody without another CAD editing package can use. Okay, question, I guess, for Andrew. Is the resolution of the component more dependent on the resin material or the machine?
Sorry, could you repeat the end of that question?
Yeah, is the resolution of the component more dependent on the resin material or the machine?
There's a bit of variance on the material side. So generally, the softer the ultimate plastic part is coming off the printer, the more that part is going to want to deflect during the print process. So we try to address that as much as possible with software and print settings. So we use different support structures, or we might peel and move layers at a different speed. So generally, we try to address that in the software and settings for the printer, so you get really consistent accuracy on the parts coming off the printer. But if you have something like an overhang feature on a part and you really don't want support structures on it for whatever reason, your best bet is to go with the most rigid material we have, which is called rigid, conveniently, easy to remember, just because you'll have less deflection there and less to worry about in terms of features moving on their own. But again, it really comes down to orientation and making sure you're using the right settings, but we try to make it as user-friendly as possible.
All right. Another one for you, Andrew. With the Formlab printer, I've seen parts that can be printed without supports, relying on the orientation of the part during building. Would Jason's component be able to be printed without supports?
No. So there are parts that you can print without supports for sure, like all of our sample parts. We print many thousands of those a month, so those are designed to print without supports. You can definitely, with Jason's part, it's an injection molded part. There are a lot of ribs, and it's a fairly large part, so you have to angle it in the build volume there. So you're going to have more unsupported overhangs that you want to have at least, a couple of support structures on, so that it's not a floating island as it's printing. And really, for what Jason's trying to do, he's trying to get answers for a manufacturing process that is injection molding. So you don't want to change that part geometry just to make it a little bit easier on the support removal side. You're really trying to solve end product questions. If you were doing something like a short run production of a printed plastic part and you knew you wanted to just throw that into an assembly and you weren't taking it to another manufacturing process, then it might be worth adjusting your geometry so that you don't have to deal with support structures as much.
Okay, another one for you, Andrew. What is the recommendation of 3D printing a part that is larger than the workspace of Formlab?
Yeah, so this comes up from time to time. So obviously you want to split that model up. I like to use alignment features on both sides of that part. So a really simple approach is to have kind of holes and dowels, use like a system like that. I personally like to have a bit more overlap and interlock between those features. So I might, in Onshape, take and extrude some tabs out and then Boolean those so they cut into the other part, so you have some cross linkage there, so you can get good alignment and you don't have to set up like a complex jig for gluing it. But yeah, it's relatively straightforward. It's basically the same mechanical design approach you would take to orienting and aligning any two parts in an assembly.
Okay, another question for you, Andrew. Questions regarding timing. What are the average times in minutes for preparations such as model preparation, fixing, CAD work, slicing, material change, transfer and start, or just an overall time?
Yeah, so there are a few questions in there. The print preparation time is quite short, especially if you have the orientation you want to print in and you click generate supports. That's going to be a couple of minutes to get that ready to send it to the printer. From there, it uploads to the printer in a minute or two. Switching materials, we use a cartridge system and a tray, a resin tank. And to switch out a different resin tank and a different cartridge, that's probably less than a minute for most people. So it's really easy to switch between materials, which is convenient when you're doing something like Jason's doing, where you're looking at different kind of mechanical aspects and you want to run different materials. You don't have to purge a machine and have a technician clean it and recalibrate and all that stuff. It's really as plug and play as possible.
All right. And what about post-processing, job removal, support removal?
Yeah, support removal, it's very geometry dependent and material dependent. So some materials it just kind of peels away almost like Velcro. Others, like our flex resin, it's softer, so you'll want to come in with like small clippers and clip those off, sand down any nubs. But yeah, we spend a lot of time on the software team trying to make the supports better and better. So we've reduced the material used. We have figured out how to use fewer support points. So it's getting better, but yeah, it's a part of virtually every print process that there's some post-processing to get your final net part.
Okay, I think we've got one more. This is could be a quite complicated one. I think it's for you as well, Andrew. We're looking at the possibilities of using printed parts for location fixtures on special purpose equipment, which can have a production life of 5 to 10 years. The components to be located are generally 30% glass-filled nylon, injection molded parts. What materials would you recommend to use in this instance?
It depends on, without knowing exactly what you're using nylon. If it's stiffness, and that's really the main attribute, then you would want something like rigid or Gray Pro, or maybe even tough if the cross section of the part is thick enough. If it's something that's going to have a lot of friction and wear, then you might want to go with something like durable. I'd say durable and tough are the most common materials on the SLA side that I run into in production environments. That said, they will probably still have a different service life than something like nylon, but the cost can be a lot lower if you're doing it yourself. So I was just in a facility in Wisconsin, and they had moved from actually machined nylon alignment pins in an operation to printed SLA out of our durable resin. And they were getting a really good production lifetime out of those and saving a lot of money versus an external vendor. So that's where I would start looking at materials wise.
Okay. All right. I think that's all we have time for this session. So I'd like to wrap it up, unless somebody can throw a quick question in there. But I'd like to thank both Andrew and Jason for joining us on this webinar today. And I'd also like to thank everybody on the line for joining us today. So with that, I'd like to say thank you once again, and have a nice day.